Native to waters from the Great Lakes to Georgia to Maine, the brook trout, better known as the Brookie, is considered America's fish by many. Something from the past, when all streams and rivers were pure, crystal clear, and ran freely through lush forest and natural wilderness.
Brook trout are one of nature's most beautiful creatures, as well as an essential part of a complete environment. Considered an aquatic canary in the coal mine or indicator species, their presence in a stream is a sign of good water quality in a healthy, functional watershed. However, air pollution in the form of acid rain and sediment in our streams from industrial, residential, and commercial development threatens the future of this Appalachian native. The decline of native brook trout signals a decline in overall watershed health. And unhealthy watersheds cannot provide clean water, a basic necessity for life, not only for the Brookie, but also for everyone downstream. Trout are members of an ancient order of fishes that had its beginnings more than 100 million years ago. An examination of their fossilized remains supports the likelihood that current forms of the species have not undergone much change over the ages. Different strains of the brook trout exist today in North America, but our discussion will focus on the brookies found in the Appalachian mountain range of the United States. The landscape you see today north of the Ohio River was strongly influenced by glaciers. As recently as 10,000 years ago, New England was covered with ice, in some places up to 1 mile thick. As the glacier gradually advanced south, it carved the landscape into mountains and valleys. Eventually, the climate warmed and the great ice sheet began to melt. As the glacier retreated north, these highly altered mountains and valleys were revealed. Melt water filled depressions in the land to form lakes and rivers. Today, rivers continue the carving process begun by the glaciers. As the water flows, it carries along with it particles of rock, sand, and soil. Some of this erosion naturally causes an accumulation of sediments that are the foundations of soils that nurture plants. However, when development occurs, unless precautionary measures are implemented, sediment accumulation can destroy fish habitat and the food necessary to sustain their lives. Before, poor forestry management and logging almost completely eradicated their habitat in the early 1900s, brookies were abundant in the mountains of eastern Tennessee. Mountaineer people exploited brook trout for food, profit, and barter. Now let's look at an amazing story about survival. In late summer and early fall, as the days become shorter, brook trout begin to seek a spawning location. The female prepares a depression in the gravel of the stream using her tail fin. This nest is called a redd. When the redd is sufficiently deep, the female releases pea-sized eggs into it. As the eggs settle into the redd, the male releases a cloud of sperm or milt, and the eggs are fertilized. Again, the female uses her tail fin to sweep the gravel back over the eggs. She then moves on to construct another redd. Incubation periods vary according to water temperature. If water temperatures rise, incubation cannot take place. This sometimes happens due to mining or development.
Newly hatched trout are referred to as alevins. They somewhat resemble tadpoles because of the large yolk sacs protruding from their undersides. Alevins remain in the protective gravel of the redd as they use up the stored nutrients in the yolk sac. When the yolk sac nutrients are gone, the young fish swims up from the redd and in this stage is referred to as a fry. After several weeks, a series of dark vertical bands called parr marks appear along the sides of the young trout, and they are now referred to as parr. As the fish grows, it loses the parr marks. This story of survival could not be complete without studying the prey and predators of the brookie. There isn't much living in the brook trout's world upon which these fish won't feed. As tiny fry, they feed mainly on microscopic crustaceans and then later on small insect larvae. As parr, they begin to feed on mid-sized insect larvae, such as mayfly or caddisfly larvae. As juveniles, they begin to include larger insect larvae. Fish, such as minnows and sculpins, along with crayfish and salamanders, become important in the diets of adults. Brook trout are cannibals and often eat smaller members of their own species. The brook trout are themselves food for many predators. Larger fish, especially larger brook trout, are the most important predator. Other predators include river otters, herons, and kingfishers, and people.
Today, most native brook trout populations occur in the northeastern states above Maryland, in the midwestern states of Minnesota, Michigan, and Wisconsin, and in the southeastern states occupied by the Appalachian Mountain Range, as far south as Georgia and South Carolina. Brook trout populations vary genetically across this range. These different genetic strains evolved for two basic reasons. First, natural physical barriers, such as waterfalls, separate many populations and prevent interbreeding, causing genetic differences to develop. Secondly, animals gradually fine-tune genetically to be better fit for the different habitats and environmental conditions that occur throughout their range. Hatchery-produced brook trout, once widely stocked by fisheries managers in an effort to repopulate streams, can disrupt this natural genetic variability. Brook trout from populations south of the New River Gorge in Virginia are particularly distinctive compared to their cousins in streams north of the gorge. According to a comparison of the two by a National Park Service biologist, southern trout are usually smaller and have more speckles, which are colored a brighter red. Their eyes, snout, and lower jaws are larger, and their pectoral fins are longer than those of the northern brook trout.
The abundance of brook trout populations and their distribution in most watersheds has changed drastically over time. Three main factors led to the declines in both the abundance and range of the brook trout. The first factor is habitat degradation. Clearing of the land along side streams for agriculture and lumber exposed the streams to the sun and caused their waters to warm beyond the optimal temperature range for brook trout. Overfishing was also a problem, as increasing human population exploited brook trout populations, sometimes using nets and explosives to catch them. And finally, introductions of non-native rainbow trout and later brown trout were made in attempts to restore trout fisheries. Rainbow trout soon became established in former brook trout habitat as it recovered from logging impacts. This encroachment by non-native trout continues in many streams today, and its control is the objective of brook trout management projects, particularly in the Great Smoky Mountains National Park.
The brook trout has a great deal of sensitivity to unhealthy water. In a few moments, we will discuss what causes water to get dirty or unhealthy for the brookie and for us. But for now, let's just remember that this aquatic canary and the food it eats not only needs cold water, but also needs clean, neutral water. The quality of brook trout habitat depends on the health of the watershed that provides the water. Only by understanding the watershed and all the factors that may affect it can we protect the streams the brook trout still inhabit. As seen in this quote, even ancient civilizations knew the importance of watersheds. They didn't use the term watershed, but obviously recognized the importance of the source of the water for their rivers. A watershed is an area of land from which surface and groundwater drain to a stream, river, or other body of water. Watersheds can be many different shapes and sizes. Watersheds are readily identifiable landscape units with identifiable boundaries that include terrestrial, aquatic, and geologic features. Focusing on the whole watershed, we can seek the best balance among efforts to control point source pollution and non-point runoff, as well as protect drinking water resources and sensitive natural areas like brook trout habitat. A good way to understand the concept of a watershed is to look at a simplified picture of a typical example. Note the large area that feeds a single stream. This large area can allow for many good and bad influences to reach the stream. The fresh water that brook trout need and that we use in our daily lives makes up less than 1% of all the water on Earth. To fully understand the watershed, we must take one step back and understand the hydrological or water cycle. This will help us understand the source of the water for our watershed. As seen in this diagram, it is the water cycle at work that gives us the seemingly endless supply of water that we enjoy. Understanding how water evaporates, collects, flows, and circulates in our watershed is the first step in protecting that water. When precipitation in the form of rain, snow, sleet, or hail reaches our watershed, it can take a number of pathways. Let's look at the diagram of the water cycle again and be sure we understand all of these pathways for precipitation. Evaporation occurs when the sun's energy creates both heat and wind. Note how the water vapor rises into the upper atmosphere where it hits the cooler layers and eventually condenses and falls as precipitation. Transpiration, as seen in the middle of the diagram, describes what happens when water has been taken up by plants through their roots and escapes as gaseous exchange through the surface of the leaves. This water vapor joins the evaporated water vapor to fall as precipitation. Infiltration happens when the precipitation percolates into the ground and becomes groundwater. Not all precipitation becomes groundwater, though. Some will fall and become surface water. The geology and topography of the land determine how surface water flows. Compact soils and steep terrain diminish infiltration and accelerate surface water runoff. In every watershed, small streams flow into larger streams, which flow into rivers, lakes, and bays. The smallest streams at the outer limits of a watershed are called headwaters. Headwaters are often located in the mountains. These headwater streams have no tributaries and are called first-order streams. All other streams have tributaries. Second-order streams form when first-order streams meet. Third-order streams form when second-order streams meet, and so on. Remember, a watershed is identified by the name of the water body that serves as the collecting basin for that drainage area. All land is a part of some watershed, so let's discover the watershed that sits directly under your feet.